Hey everyone, thanks for coming back to this PLASTICAST. We're joined again by the guys from OPR. We're here with Andy Schroeder and Scott Farling of Ocean's Plastic Recovery Project. And last time we spoke about the conception of OPR and what they do in Alaska, the amount of marine debris they recover daily, monthly, and yearly, and the different kinds that they encounter, as well as the effects on wildlife. And today we're going to talk a little bit more about OPR's mission and go into a little more depth on some of the outreach and research and recycling programs that they do. So I want to give you guys the floor to talk a little bit more about your mission.
Thanks, John. So our mission is to remove ocean plastics from the natural environment, to identify and develop reuse and recycling and recovery alternatives for ocean plastics, and share what we learn with the global community. And the way we really do this is we break it out into 4 focus areas. We have the collection piece, we have an outreach element, research element, and an education element.
It's hard to know, but if you were to look at the North Pacific Gyre and take a pass through the middle of it and collect everything you saw, you would likely find a bunch of plastics from Asia, from a particular set of large but yet still developing nations. Consumer plastics, you would find some byproduct from fishing, you would find some industrial plastics, just blanks from flip-flops come to mind. For some reason you find a sheet of flip-flops with the shoe holes cut out of them. Somebody's recycling those and using them for floats in some kind of fishing aspect, and we find those washing up. But I think you would find the same composition of ocean plastics roughly in the middle of the Gyre as you would on the Alaskan coast. And so my belief is that this stuff is in circulation, and it may come on and off a beach, in fact, several times. And so we're pulling it out of the ocean by pulling it off the coast. It does more harm when it's in the near coastal zone than it does in the Gyre, I believe. And especially in Alaskan waters, which are more nutrient rich and productive and economically important. So our collection right now occurs in the coastal environment, and primarily that's been vessel based. We contract with vessels. We bring either volunteers or professional paid crews and ferry them to what the most part is remote coastlines. Largely uninhabited in over 30,000 miles of Alaska coastline. Far and away, most of that is uninhabited, inaccessible by road. Our crews pick it up. We get it back onto a vessel one way or another on larger scale cleanups. That can be helicopters. More often it's skiffs, and load the vessel up, land it at a port somewhere. There's a sorting and particle reduction process, which maybe we'll talk about later. But get it out of the marine environment is priority number 1. That's the C in collection. Outreach is initially not why I started it. I am not an educator, not a communicator by trade. I'm a boat captain. There was a point though, when I said to myself, I can't keep doing this. Some of the places we work are so far from anywhere. I was on Kodiak Island, which is 100 miles from the port we were going to land this stuff on. There was nothing but ocean horizon in all directions. There was hundreds of thousands of pounds of ocean plastic in front of me on the beach. And I had a crew of 12 people. We were our own little enclosed community for weeks at a time. This was in the aftermath of the Japan tsunami. And I remember my first day walking the beach on Kodiak Island saying to myself, here I am again, a new beach, a whole bunch of work ahead of me, and I could easily dedicate the rest of my career to this, and nobody would know about it. Maybe it doesn't even put a dent in things. And so I said at that time, and continue today, to say, I'm going to do this, but I'm also going to tell a story, and we have to contribute to some sort of global narrative on the ocean. And so documenting that and reaching out to people and showing them what we're doing is now a part of every cleanup that I do. I am always doing outreach, both, about our cleanups, to try to tell the story, to slow the inputs, to get people to be more conscious consumers, more careful about disposal of their plastics. And I think it just has to go part and parcel with the collection.
Yeah, it's when Andy and I first started working together, I thought I would just link him up with some folks that are already recycling ocean plastics. And mostly what we found were people were using end-of-life gear, or they were recycling ocean-bound plastics, which is all very helpful. But it wasn't helping us solve our problem of what to do with what we've collected. And the more we searched, we realized that there was really an opportunity to do some fundamental research on determining what is the best thing to do with the materials we collect, and how do we break them into different categories of materials, different grades of resins, different levels of degradation, and then determine what the best end of life is for the particular material, whether it really does belong in a landfill, or can we recover some energy from it, or create new chemicals from it, or can we mechanically recycle it back into a product that's useful. And so that's what we've been working on, and we've partnered with a number of universities, including Oregon State. We're working with Oregon State mostly on pyrolysis and gasification. We're also working with them on some mechanical recycling aspects of ocean plastics. We have a good partnership with Western Washington University, where we're really looking deeper into the mechanical recycling opportunities. And then we've got a new program, but hopefully it will grow over time, with Purdue University to look at chemical recycling pathways. Beyond the universities, we're also partnering with a number of companies that have technologies we think would be suitable for ocean plastics. And so we've got a number of partnerships with industry as well. And really what we're trying to solve with the fundamental research is to just determine what's the best thing we can do. How can we sort these materials in the most useful way to create feedstocks for some downstream process, so that we can capture value. And then beyond that, we're also doing some more applied research, where we have clients that want a specific product and they want it derived, at least in part, from ocean plastics. And so we're working on specific projects with a few companies, where we're looking at taking ocean recovered nets and lines and making products from those. We're also doing some stuff with some rigid high density polyethylene, and we'll continue to do those projects as well. And anywhere where we can find a demand for the material, and we know we've got the supply, we try to find a way to link those two. The final component of our efforts is the education component, and that's the one that I think has just grown and grown as we've been working, and continues to grow. And initially, our hope was to get students involved and interested in solving this problem. And so we've been working to get high school students up on our cleanups. We've brought some of our undergraduate researchers up to Alaska to help with the cleanups. And more we're seeing opportunities to use this environmental problem solving of ocean plastics and what do you do with them, as a way to draw young people in to study this work. Which maybe they can go on to solve ocean plastic problem, or just our general recycling problems. So that's an area where we're very interested. We're still growing that part of the program, though, but look forward to continue to build partnerships.
When you recover plastics, how do you all determine what constituents are in them through Raman spectroscopy or FTR or whatever technologies you use? And how do you determine where it's currently at in its life cycle, to know how much energy you can derive, or how far you can take it in the recycling process?
There's a combination of knowledge of the different materials. So having worked in the space for a long time, you develop an understanding of what plastics are used in what applications. So you get a pretty good head start there. And then we use near infrared. That's the tool that the Ocean Plastics Recovery Project has at our disposal. But then through our research partners, we start looking at things like FTIR and DSC to really dig in to better understand and characterize the resins. And as we do this, we continue to document what we're finding. So we know, if we find something that we don't know what it is, but we start to develop an understanding of what materials are used. We keep track of that. So, for example, trawl floats are mostly HDPE, but we have found some that are ABS resin, for example, and we try to keep track of what we're finding in these different applications so that we understand the waste stream better.
So I'm wondering what kinds of plastics you all encounter, and if there's like something that's dominant or a few things that are dominant.
Do you want to take a shot at this, Andy, first?
Well, yeah, and then Scott is going to come in and correct me because I spent a long time, thinking I knew what I was looking at, or possibly using the wrong name. But just briefly, we definitely see a lot of high density polyethylene. That's because it's so common and in the marine industry, buckets and things like that. So definitely a lot of HDPE, not a lot of films or other, mostly rigid, maybe because that can trap a little bit of air. Polystyrene, definitely. And in marine applications, polystyrene is used in places where you're not always looking, because it is a way of taking a small amount of matter and blowing it up huge. And it's used for flotation. So it kind of gravitates towards marine industries. I've seen pilings completely filled with EPS. There are certain floats used in the oyster and aquaculture, I believe in Japan, which we started seeing show up after the tsunami, which is basically, think of a 55-gallon drum, a cylinder the size of a barrel, that is just EPS. And it's a nightmare to handle those, because you just see it flaking off. Once it loses its glue or whatever holds it together, it starts, every time you touch it, little nurdles of it come off. And you can see how this is sort of just disintegrating into the environment, small, edible piece by piece. And then often when you go inshore, you find them partially buried or completely underground. So we know they stick around, they last, and end up sort of being absorbed into the natural environment.
Yeah, I kind of second what Andy said there. High density polyethylene seems to be the most prevalent. It's also the most prevalent resin used in the world, so that makes sense. There's some natural sorting that happens by the ocean, in that polyethylene and polypropylene and some of the expanded materials, the foamed materials, those are what float. All the other resins by nature will sink in seawater, but it depends what their form is, right? So Andy mentioned if they trap air. So I remember the first time I met with Andy, he talked about the large amount of PET bottles. I was like, nah, you must be thinking of something else. There not that much PET would make it, it sinks in water easily. But so many people put the caps back on, or the bottle can still just float and lay sideways in the water and not take on enough water to sink. So we see a lot of PET bottles, a lot of water bottles, soda bottles, that type of stuff. There's a lot of polyolefins in the nets and lines. Again, that came as a surprise to me. I thought, not having worked in the fishing industry or around a fishing industry, I thought nylon was the predominant material, and it is used in several applications. But what we find are the polyolefin nets and lines. We do find quite a bit of polystyrene, as Andy mentioned. It's the big floats are probably the main thing we find. I've saved some of the food service stuff, and I think I'm probably not quite to a gram yet. Out of tens of thousands of pounds, we just don't find much food service foam. But we do find those big expanded polystyrene buoys or floats, or I even found a tire that was filled with polystyrene, and I don't know how exactly what they were trying to do with that, but there's certainly, you find it, and it's one of those ones that you really want to clean up right then and there, because anytime you leave something like that has the ability to degrade easily and break apart, you're just causing more problems for wildlife. Little bits of PVC in the buoy markers and stuff like that, bumpers for boats, but for the most part, it's polyolefins, quite a bit of PET, and some amount of polystyrene in the foamed form.
I was commenting on I think to Scott once on how remarkable it is that people litter, people will throw away these PET bottles, but they will take the time to put the caps on. And I would say something like, it's amazing. Everybody, every PET bottle has a cap on it. And I think Scott's observation was, yeah, the ones you find do, we don't have collection off the seafloor, and it's scary to think of how many bottles didn't make it to us and are sitting on the ocean floor because again, because of that cap. So
is the cap also made of PET, or is that polypropylene?
It's usually polyethylene or polypropylene, but not enough to necessarily make it float. But the fact that you've trapped the air is what really carries it along.
Is there a universal standard for what I, as like a consumer putting into my blue bin, can recycle nationally or globally? Or is there sort of like different standards for different countries, or what the infrastructure they have capable of doing it?
Right. That last thing you said is exactly what it is. It has to do with the infrastructure that's available in the region. Most plastics that you encounter on a day-to-day basis are recyclable. Whether your program allows it or not, they are technically recyclable. But the way we use that term, usually what we're saying is it recyclable in my program, in my curbside collection program? And then that comes down to a matter of what's technically possible, what the sorting facility has the capability to sort out, and what markets do they have. So if there are no markets, there's no money in doing the sorting, and so there'd have to be another incentive for extracting the material. So it does vary widely, and sometimes in a very small geographic region, you can have a lot of different programs. So for example, I used to live down in San Francisco, and in the city, I could put every bit of rigid plastic in my bin, and they had a very comprehensive MRF, material recovery facility that could sort those materials and get them to market. But when I drove across the bridge to where I worked, I could only put number 1 and number 2 narrow neck bottles in my curbside or in the program there at work. And so you can see a lot of differences just based on what facility capabilities are in your region. I think Oregon has done a pretty remarkable job in the way they've looked at it from a state level. And so they have, it doesn't apply equally to different parts of the state. They take into consideration the size of the area, how far it is from a processing center, and what the population is and things like that. But they've got a harmonized system across the state for what must be recycled and what you need to add to the list if you're in a metro area. So that's another good program. But really, a lot of these materials can be recovered and recycled, and that's what I think we should be pushing towards. There are models, business models, and infrastructure that could be employed to really recover a lot more material. And I think we'll see that happening. We're already starting to see a lot of investments in the U.S. after China's national sword. We used to be able to export a lot of our lower volume and difficult to recycle materials to China. And that outlet's no longer available. And so what we're seeing is a lot more investment in the U.S., and I hope that continues.
Is there anywhere for Oregonians to look online to see what they can recycle in their region? Yeah,
most communities have their own recycling guidance on their municipal website, or either you can go to the town's website or the city's website, or you can go to the hauler's website, and either one would provide the information. If you're in the Portland metro region, we have the Oregon Metro government, and they have a find a recycler application on their website where you can type in a number of materials and it can tell you all the places you can take it. So there's a lot of resources out there to find out what to do. And that's the big thing is, just putting more stuff in the bin without a program to deal with it, without a solution waiting for it, doesn't help. It just ruins the economics of the recycling industry. So understanding your program and then following that program. And if you want to put more stuff in your bin, then go to your community meetings and lobby to get the program changed, and be willing to pay another $1 a month in your bill, and stuff like that can go a long way.
Thank you. That's really insightful. I've put things into the bin that I didn't know if I could recycle or not, and I'm like, maybe it will, I don't know. And then I've seen, in other instances, like things that I do know you can recycle have like contaminated food on them, or mold growing or something. What happens to that recycling that goes in there that either isn't meant to be recycled in that region, or maybe has food scraps on it?
Well, largely the material recovery facilities will try to capture everything they can. They want to recycle. That's what their goals are, but they need to be able to make money off of it. So if you put something in that's not part of the program, but it happens to be something they have a market for, and there's enough of it, and then they can sort it out, there's a good chance that maybe it'll get sorted. But really, most of the stuff you put in that's not part of the program, it's not part of the program because there's nothing in the system designed to sort it out. So it ends up going to landfill. It just takes a much more costly route to get there. So it costs the extra hauling to the material recovery facility. It costs money for the material recovery facility to dispose of it. And it uses up capacity on the line. And anytime you're using up capacity on a sorting line, you're decreasing the efficiency of the line. So not only are you adding costs, but you are also, you're making that system run at a higher capacity than it would have to, and which potentially you start to lose good recyclable materials because of that. The good thing is most people clean out their recyclables to a satisfactory level. And it doesn't have to be washed spotless, but it should be rinsed and free of food. The things that are most likely, in my opinion, I've studied a lot of recycling streams, and the things that always jump out to me that nobody spends the time cleaning are peanut butter jars, and those plastic trays that a chicken breast comes in, or whole chicken, I'm sorry. Those tend to come to the facility pretty gross. And they can get sorted. If you scrape your peanut butter jar pretty clean, it's a PET jar, and it's typically sorted with near infrared, not so much in Oregon, but in most states, they use near infrared for sorting that. And as long as there's not enough weight of food in there to mess with the ejection of that from the stream, they're shot out with little blasts of air. And so for example, if you put a half a bottle of, bottled water and you leave half of it full of water, it's going to go to waste, because what's going to happen is as it goes through the stream, we're going to try to eject it with a blast of air, and the air is not going to be enough to push it into the good stream, into the recycling stream. So it'll go to the waste. So it's important to have your containers empty and clean. That's, if you want to market your materials, you've got to be selling a clean product.
This is really fascinating, guys. I'm running low on time, but I just wanted to ask if there's anything else that you guys wanted to talk about that I haven't captured that you guys really want to get across.
I think it's been good and instructive for us to get together and say it and restate and be able to kind of really reflect out loud on what we've accomplished and what we do. So it's been good for me and enjoyable podcast.
Yeah, definitely. Look forward to seeing some more of your episode as well.
Yeah, well, thanks so much, guys. Thank you for the work you're doing. I wish I could see you in action and just visit Kodiak and see how that's all that operation is like. And I look forward to seeing your film one day, and I hope that you get that funding.
Thanks very much.
Thank you.
Yeah. Well, thank you guys for watching OPR with Andy Schroeder and Scott Farling. I'm John Dickens, and this is PLASTICAST, and we'll see you next time.